So, today I will demonstrate single slit diffraction experiment. So, aim of this experiment is basically measurement of the width of the slit. So we have a slit, single slit, its width is B. So, now parallel rays are falling normally on this slit. Okay. So, this red part is basically opaque and this rectangular part is open. So, light will pass through this slit, and after passing through the slit, if slit width is its width is in the order of the wavelength of this light, then we will see the diffraction pattern on the screen. Okay. So, the diffraction pattern we will see on the screen is like this. So, this is the basically intensity variation on the screen we will see like this. Okay. So, this one is called the basically central maxima, this is called central maxima, and this other one is secondary maxima, and between these maxima these are the minima, it is the dark point, this dark point. So, minima, maxima we will see here two kinds of maxima. This one is central maxima, it is we get generally at direct position. If you this dotted line follow, so at direct position we see this central maxima, and both side of central maxima we get the secondary maxima, and between secondary maxima and central maxima we get the minima. Okay. So, intensity variation as a function of beta, equal to I0 sin square beta by beta square. What is beta? Beta is equal to pi a sin theta by lambda. So, how this formula has come, that I have discussed in previous class, okay, during the discussion of the diffraction in general. So, beta basically depends on the wavelength. So, in our case, when we will do experiment, wavelength is fixed. We will take a laser light of wavelength of I think red light we will take. So, 632.8 angstrom, not angstrom, this nanometer, 632.8 most probably, we will check it. So, this lambda is fixed for our experiment. Now, a sin theta, what is a? Sorry, here I have written B, but they are written. So, it is basically I will change it A. So, the slit width is A. So, it will depend on A and it will depend on theta. What is theta? Theta is basically diffracted angle. So, this light from this slit, it will be diffracted in different direction, and say here I have shown this a set of parallel rays, okay, from middle point and this end, in between others will be there. So, these sets of parallel rays, so they will interfere for this angle theta. So, angle theta will vary, so we will get different sets of parallel rays, they will interfere, okay, and that so that is why we tell diffraction is nothing but the interference among secondary wavelets. So, when this wavefronts falls on the slit, then on the slit, each point will act as a secondary source. Okay. So, from each point again we get the secondary wavelets. So, that is the high gain principle. So, now these secondary wavelets we have this. So, basically these secondary wavelets will interfere and we will get this diffraction pattern. So, these interference basically will happen at different angles. Okay. At different angle we will get set of parallel rays and they will interfere for that angle, and we will get the, depending on the interference condition, intensity will be maxima or minima. So, already we have done experiment on interference. So, we will get the intensity variation due to interference. Okay. So, this is basically theta. So, obviously that theta will vary on the screen. Basically this theta will vary, beta is varying means for different theta we will get for a particular slit width. If we keep the slit width constant, okay, for a particular slit width we will get this variation because of variation of theta, because of variation of theta. That means that because of variation of beta, because beta is related with this theta following this. So, now here intensity, when intensity will be maximum, when intensity will be minimum. So, from here you can find out. So, now if beta equal to 0, sin beta by beta whole square. So, for beta equal to 0, then if you take limit beta tends to 0, then it is 1. So, this intensity will be I0, maximum intensity will get when beta equal to 0. And for any other value of beta, so this intensity will less than I0, and when theta will increase, obviously you can see this theta is increasing, beta will increase, okay, beta will increase. So, if you know beta, so sin beta by beta whole square, so you can find out this factor and you can get the intensity. Okay. So, this I0 equal to I beta equal to 0 equal to I0. So, that we get for beta equal to 0. So, this is the basically central maximum, we tell this is the central maxima for beta equal to 0, and then beta is varying. So, this intensity drastically falling. Okay. So, then for beta equal to plus minus pi plus minus 2 pi, that means it is beta equal to m pi, what will happen? Beta sin pi, sin 2 pi, sin 3 pi, etc. So, 0, but beta is not equal to 0. So, obviously this intensity, this factor will be 0. So, I beta will be 0 for beta equal to m pi. So, this is called minima. So, this is called minima, diffraction minima, okay, and that minima will get for m equal to plus minus 1 plus minus 2. So, this plus minus this term is coming because this side, both sides symmetrically will get the order. Okay. And so, from here you are getting basically if beta equal to m pi, beta equal to m pi. So, a sin theta from this relation, a sin theta equal to m lambda, you will get this condition a sin theta equal to m lambda. So, this is the condition for diffraction minima. What are those diffraction minima? These minus pi, minus 2 pi, plus 2 pi, etc. That will be the diffraction minima. Okay. And diffraction maxima also one can find out, but we will not go to that. So, this maxima, generally secondary this maxima, here at theta equal to 0 we get the central maxima, but secondary maxima we supposed to get uh, at 3 pi by 2, 3 by 2 pi, that means 1.5 pi, okay, and then 2.5 pi, but it is not exactly 1.5 pi, it is slightly less than that, it is the 1 point I think 43 pi, and this other one is 2.47 pi, it is not 2.5, 2.47 pi, okay. So, why it is not exactly 1.5 or 2.5, that can be from graphical method one can find out. So, we are not going to in that direction. So, here for this experiment our working formula is A sin theta equal to m lambda. So, that is for minima, diffraction minima. So, what we will do to measure the width of the slit, if we can find out this theta value, if we can find out this theta value for different minima, okay, then we will be able to, lambda is known to us, m also will be known to us, because this is the first order minima, then second order minima, third order minima. So, m will be 1, 2, 3, okay. Then we can find out if we can measure theta for different order. So, we will get A for different order, okay, and then we take average of that, that will be the slit width of single slit, width of the single slit, okay. So, for doing experiment, so we will use these tables. So, we will note down the wavelength of the light we will use for the experiment, then we will note down the distance of the slit from the screen or from the detector. So, that is capital D. So, that we will note down what is the distance between slit and the detector or screen. So, that we need for calculation. So, that we will note down. Now, what we will do, using the photo detector, photo cell, we will measure the basically intensity at different place, okay. So, different place means you have to move across the vertical direction. So, across the vertical direction this intensity are varying. So, that photo cell will move, say we will take extremely left, okay, then we will move from left to right, and for each position we will note down the intensity in terms of current, photo current or photo voltage, okay. So, this, if it is say 0 or x 0 and other that distance if it is x. So, from this center where theta equal to 0, so this distance will be x minus x 0, okay. So, and this, if it is x from the center x minus x 0, okay. So, sin theta for small theta, sin theta equal to tan theta equal to, you can write this divided by this distance. So, x minus x 0 divided by d, capital D, that as I told, that distance between the slit and the screen, distance between the slit and the screen, if it is d, capital D. So, this distance from the center, so that is x minus x 0 divided by this distance screen and slit, that distance capital D, so that will be sin theta. Okay. So, basically we'll measure intensity for different value of x. For different value of x, initially we will note down this x0. So, then basically x versus the intensity of photocurrent in terms of photocurrent or photovoltage we have to note down. Then we will draw the graph, we will draw the graph, okay, as a function of theta. Okay. So, we can find out the minima at which angle we are getting minima. Okay. So, we will note down that angle, and then from this relation A sin theta equal to m lambda for defined order theta, from the graph we will know, and then we will find out the A. So, that we have to note down. For that, this is the table. So, intensity distribution with respect to the position of photocell position, okay, with respect to the position of the photocell position. Okay. So, at x0 equal to position of central maxima, okay, we will note down, and then position of photocells we will note down in centimeter or millimeter whatever. Okay. And then theta will be x minus x0 divided by d, as I explained. Okay. For that theta, when we will move from left to right, so how this photo current I is varying or photo voltage are varying, so that we will note down, okay, as a function of theta or as a function of position x, okay, of photocell. So, we will note down and we will find out the basically the intensity at different angle. Similarly, we will note down, so from left to right when we are going, so we will note down again from right to left when we will move, from right to left we will again note down the x position corresponding theta and then corresponding intensity. So, basically we will get two sets of data. Okay. Just this is a basically repetition of the measurement when we are moving from left to right, then one set data, and when we are moving right to left, say another set of data. So, theta versus the intensity, that data we will get, and then we will measure slit width using the travelling microscope, okay, for comparison whatever the experimental we have measured from diffraction experiment. So, we will verify using the travelling microscope. So, we will note down the vernier constant of the microscope, and then we will take reading of microscope corresponding to left edge of the slit, main scale reading, vernier scale reading total, say if it is L. So, similarly for the right edge of the slit we will note down the reading, and then width of the slit is basically A equal to R minus L. Okay. So, that we will get from microscope, and from our experiment, from our diffraction experiment, basically from graph we will get the value. So, that width of the slit from the microscope measurement, this mean value of A we will get, and from experimental diffraction experiment we will get. So, this we can compare. So, basically we will take data and then we will plot intensity distribution of the diffraction as a function of angle theta. This photocell should be parallel to the plane of the slit, of course. So, from table 1 we will get this data, and then we will find out the width of the given slit from the plot, as well as we will measure using the microscope, okay, travelling microscope. So, for comparison. Okay. and the error calculation for this is very simple. A sin theta equal to m lambda. A is basically difference of two reading R minus L, and sin theta is basically x minus x 0 by d, as I told. So, here also this d is the distance between the slit and the skin or photocell. So, this d also depends of two reading. So, here if you take del A by A, so then m is basically order count, so no error, lambda is given. So, error will come from d and x minus x 0. So, basically this 2 del d by d plus 2 del x by x minus x 0, this factor 2 we have written because of the difference of the reading. Okay. So, both d and this x is the difference of two reading. So, that is why this factor 2 has come. Okay. So, now I will demonstrate the experiment in our lab. So, this slit basically I think from here you can see. Okay. So, that slit I can rotate and change the slit width. I think I am increasing slit width, you see slit width is increasing, it is a very large slit width. So, I am now decreasing the slit width. Okay. I am now decreasing the slit width, right, just rotating the screw, now it is 0. Okay. So, I can change the slit width and keep, say this is the slit width, keep at a particular value. So, this is the A, right. So, this type of slit we are using in our the same slit we are using here. So, this is the slit. Okay. This is the slit, same slit. So, I have kept at a particular width. So, I will not disturb that width. Okay. Now, this is the laser. Okay. So, its wavelength is as I told 632.8 nanometer. So, this laser beam is falling on this slit, right. So, laser beam is falling on the slit. Now, here this is a screen, here this is a screen, right. So, we are seeing the diffraction pattern. Okay. So, we are seeing the diffraction pattern. So, this is the central one, highest intensity diagram you have seen. In the diagram you have seen the central one will be highest intensity, central one will be highest intensity, right, and then the side one, the secondary one, that intensity will decrease, and between this maxima there are minima. Okay. So, you are getting the central maxima, okay, and then this first order, secondary maxima, second order, third order, fourth order, fifth, sixth, 7, 8, I am able to see many order. Okay. So, this is because of laser light we are able to see many order, with other light we cannot see because this laser light have higher intensity. So, this other side also first order, second order, secondary maxima, third order, fourth order, fifth order. Now, between these secondary maxima you can see the gap, okay, there is no light. So, that is basically the diffraction minima, and the condition for that minima A sin theta equal to m lambda. Okay. So, we will measure the intensity as a, so we will use photocell. So, if photocell, if we vary, okay, so for the we will note down different position of the photocell and corresponding photocurrent or photo voltage we will note down. So, that photocurrent will be proportional to the intensity of this light. So, that is the property of this photocell. Okay. So, then we will get this x versus the photocurrent, and central one, if I take that reading as a x 0, it can be 0 also if you adjust the position of the photocell, but that you do not need. So, this you can take as a x 0. Now, with respect to the central maxima, just we will vary the position of the photocell and we will note the. So, we will start from say left and then left to right we will move and take the reading for different position of photocell. We will note down the current photocurrent. So, this will be one set of data, and second set of data you can take when you are moving from right to left. Okay. So, this is the task. Then we will plot the intensity photocurrent versus this x minus x 0 or this angle theta equal to x minus x 0 divided by d. So, d will remain constant, only will vary the x. Okay. So, so here just I would like to show you the, because in this formula what you are getting, as I showed you this, as I showed you that A, so basically A sin theta equal to m lambda, right. So, A sin theta equal to m lambda, and then sin theta equal to x minus x 0 divided by d. Okay. So, from here you can see that for a particular order, if it is for m equal to say 1, okay. So, this angle is say theta 1, m equal to 2, this angle is theta 2. Okay. So, for a particular distance of the screen, whatever theta 1 you will get, if you increase d, what will happen? If you increase d, then this value will decrease. If you increase d, this value will decrease. Okay. But theta you cannot, because of the position of the screen you cannot change theta. So, that theta is defined by the slit width. Okay. That theta is defined by the slit width and okay, diffracted angle. Okay. So, what I am trying to say, if d increase, so this value x also increase for the same order. That means this first order will move this other side. So, when d will increase, then what you will see? You will see that x also, this order will move other side. So, I am increasing, see, I am increasing, you can see the separation is, I think, let me decrease because not much distance that side. So, now distance I am decreasing, so this order will be, you see, closer, it will be closer. Okay. So, x will decrease because d is decreased, x will decrease to keep this theta 1 same, because that is coming from the slit. Okay. So, this fins, that spacing, it will depend on the screen distance from the slit, right, screen distance from the slit. Also, that theta will depend on A, right. So, if A is increase or decrease, okay. So, order, that position of the order will change, or if A increased for the same order, theta will decrease. If A increase to for same order first, so it has to be lambda, so that means theta will increase for first order minima, okay. That means it will A increase, it will decrease. So, it will come towards the first order, that will come towards the central one, central maxima. If theta is decreased, then sorry, A is decreased, theta will increase for same order. That means this first order will move away from the central one. So, that I can demonstrate, I can show you. I am changing the slit width. So, now I am increasing the slit width, you know, sorry, I think no, I decrease the slit width. So, it is 0 now, okay. Okay. No, I think we have to show that one, okay. Okay. I am increasing, you see this first order minima, so it is coming closer to the central maxima. So, all order are moving towards the central maxima, you see this central maxima, okay. So, that is the effect of the width of the slit. Now, I am decreasing, you see the central maxima are moving, not central maxima, that minima are moving away from the, so distance are increasing. So, theta are basically increasing, right, x by d, so that is the angle, see. So, we will keep at a particular, angle, okay. So, that means we now we have kept not a particular angle, particular A slit width. So, then we will not disturb that one. Also, as I showed this, if you change this distance, so also it is varying, okay. So, this also we have to keep at a particular distance, okay. So, slit width for a particular slit width A and for a particular distance D, that distance between the slit and the screen, okay. For this we will do the experiment. What experiment we will do? We will measure the intensity of the diffraction pattern as a function of theta, means as a function of position of the photocells, okay. So, from there you can find out theta, okay. So, now I will remove the screen, okay. Now, I will remove the screen. So, this is the photocell, okay. So, now that diffraction pattern is falling on the photocell. So, photocell will give photocurrent or photovoltage, okay. So, this we are measuring using the multimeter. You can see this we will measure using the multimeter. So, I think if we can switch off, okay. So, just I have, so it should be 0. So, we should switch off the light. I think these light have very high intensity, you cannot change, okay. So, this light, if others room light is falling on the photocell, it is giving current, okay. So, now you see this is the photocell and it is on the stage of a micrometer, okay. So, here is a basically screw gauge, is a circular scales are there as well as linear scales are there. Okay. So, basically if I change, just rotate this circular scale, this position of the photo cell will change, and that I can note down. So, here there are in circular scale there are 100 division. So, if I rotate once, so 1 millimeter means I think you can see. So, here is a millimeter scale and here is a circular scale. Okay. So, it has 100 division, 0 to 100 division. So, if I rotate one complete rotation, then it will be here, it will move by 1 millimeter. So, it is the least count is 0.001 centimeter or 0.01 millimeter, right. So, basically you have to take reading from here. So, now I will show you the basically the reading. So, let me take is extremely, I think you take extremely left or right, anyway I am just setting at the center. So, when I will get the maximum current, maximum voltage, current or voltage whatever. So, this is the central position, is the reading is giving 190, what happens? I think, okay. So, because from outside if light falls on this, so I just stopped it, it's it has some, still it is, I think if I can switch off this one, so it's I have changed scale. So, if I just, oh, it's a going minus negative sign. So, it's so 180, this in millivolt, this 192, it is giving 192. So, if I change just this intensity will change, you see now from central maxima it is going towards the first minima. Okay. Its reading is getting change, reading is getting change. So, for each position, you know, this we have to note down. I am not noting down, just showing the variation of the intensity. So, I am about to get to the, yes, about to get to the minima, but it is fluctuating, it is heavily fluctuating. I do not know, this camera light is falling on it. So, this basically this way you have to move and note down the photocurrent, and that photocurrent corresponds to the basically intensity of light, right. So, now what we will do? So, we will use this travelling microscope, okay, and put this one, I think, yes. So, we have to adjust height either here or here, okay. I think let us put light here, then we will see. Yes, I got, but I have to. Yes, I got nice. So this processor I have to, anyway. So I got the slit. So actually I have to take out that one and put here. So this is the another slit. So just set here, and then you focused and put, you see, use this scale, horizontal scale, and crosswire you should set at right edge or left edge, take the reading, vernier constant you have to find out. Okay. So it's I can see the 50 division and corresponding, anyway. So you know how to find out, many times I have discussed. So you take the reading for left edge and then move again to put the crosshair at the other edge, take the reading. So difference of this reading will be the slit width. Okay. So from microscope whatever value we got, and plotting the graph of intensity, means photocurrent, versus the angle you will get x minus x 0 divided by d. Okay. If we put plot graph, from graph you will see the intensity variation. So find out the minima, first order minima, second order minima. Okay. And what is the angle for that? So for first order, second order, third order, you find out this angle, put in this formula, a sin theta equal to m lambda. So sin theta is known from the graph, theta is known, means sin theta is known, m also known, order. Okay. So lambda also given 632.8 nanometer. So you can calculate a for first order, a for second order, a for third order minima. Okay. And from both side you can get, so you will get few readings and for a, and you can take average of that, that will be the slit width. Okay. So I think I try to show you the pattern of the single slit diffraction and how to measure them, that I try to describe. And only reading I cannot take because it takes long time. So that is your job to take it, but following the procedure as I explained. So I will stop here. Thank you for your attention.